In this video, we're going to discuss transformations, specifically reflections. There are two ways we can reflect a function. Let's say we have the function y is equal to x squared. This is a basic parabola, the parent function of a parabola. One way we could reflect it is if we would reflect it across the x-axis. It would flip over the x-axis and it would end up looking like this. And another way we could reflect functions is by reflecting them about the y-axis. Let's say we have y is equal to x cubed, which looks something like this. We can reflect this graph about the y-axis over this line, and it will end up looking something like this. Let's look at how we would do each of these mathematically. Well, we have y is equal to x squared. Let's start with that one. And we want to reflect it about the x-axis. When we want to reflect any function about the x-axis, you need to multiply the function by -1. So let's say we have a function y is equal to f of x. To reflect it across the x-axis, you have to rewrite this as y is equal to negative f of x. So let's say f of x is equal to x squared. When we want to reflect it across the x-axis, we rewrite that as negative x squared. Let's graph these. Let's just clear this out. Our basic function is y is equal to x squared. Then when we reflect it, it's negative x squared. And we'll graph it in zoom 6 for zoom standard. Parent function and the reflection. Let's say we had a more complicated question. Let's say we have y is equal to x squared plus x minus 3. When we want to reflect it across the x-axis, we have to multiply each of the terms by -1. So we have to do y is equal to -1 times x squared plus x minus 3. And we could distribute that -1 if we want. It'll end up the same thing. We could distribute this and it becomes y is equal to negative x squared minus x plus 3. And let's graph the parent function, which we just decided is x squared plus x minus 3. And let's graph the transformation, the reflection. Y is equal to negative x squared minus x plus 3. And zoom 6 for zoom standard. That's the original function. And that's when the function is reflected across the x-axis. Now let's look at how we can reflect functions across the y-axis. Let's say we have the function y is equal to f of x. To reflect it across the y-axis, we have to multiply just the x by -1. So to reflect across the y-axis, we rewrite this as y is equal to f of negative x. Notice how here, when we reflect it across the x-axis, we had the negative outside. Here we have y is equal to, let's say we have y is equal to x squared. It becomes negative x squared to reflect it across the y-axis. The negative goes inside. So unfortunately, the x squared and negative x squared is not such a good example because a parabola, you might remember, is symmetric across the y-axis. So even when you reflect it across the y-axis, it looks exactly the same. And that makes sense because negative x squared is the same thing as x squared. So we're going to have to use a different function. We're going to use the function y is equal to x cubed. Let's say our basic function is y is equal to x cubed, and we wanted to reflect this function across the y-axis. We would negate our x, so y is equal to negative x cubed. And let's graph these. X cubed and negative x cubed. Zoom 6 for zoom standard. It's our original. And that's how the graph looks if you imagine it flipping over the y-axis. Let's look at one more example of reflecting across the y-axis. Let's do a more complicated one now. Let's say we have the function y is equal to x cubed plus x squared plus x. And we want to reflect this across the y-axis. So what we're doing is, let's say this is f of x is equal to y, which is equal to x cubed plus x squared plus x. What we're doing now is f of negative x is equal to y, which is equal to, wherever we see an x, we're replacing it with a negative x. This becomes negative x cubed plus negative x squared plus negative x. Let's graph these two. The original was x cubed plus x squared plus x, and the new one is negative x cubed plus negative x squared plus negative x. And zoom 6 for zoom standard. That's the original function, and that is the reflected function across the y-axis.